Hey everyone, welcome to Data Engineers Lunch number 24. We are almost at halfway into 1 year of Data Engineers Lunches. Today's topic is going to be on pandas for data engineering. If you missed last week's where Obi began the series on Python ETL tools, he covered an overall of the tools that we'll be covering, but he also did demos for bonobos. But today we're going to be covering pandas. Obi will be our speaker today. He's an engineer here at Anant. Currently, our organizers for this event are Rahul. If you are interested in becoming a co-organizer, essentially your roles would be helping spread the word about the event, help find sponsors. If you are interested in becoming a co-organizer for Data Engineers Lunch, don't hesitate to reach out to Rahul at rahul@anant.us. We are a part of Data Community DC, which is an inclusive community that no matter your race, gender, religion, etc., everyone is welcome and everyone is welcome to present, speak, and learn. Data Community DC is a part of a bunch of different organizations like DataViz.dc, Full Stack Data Science, Statistical Seminars. As I believe Mike dropped in the chat, there are some interesting events coming up, and you can find more about that at datacommunitydc.org. And you can find other events across all the different communities on Eventbrite or Meetup, etc. So what did we cover here? We essentially covered data engineering. What does that include? Data cleaning, ETL, engineering. So that way we can take data, format it, etc., and give it to either an end user versus in a BI environment, business analysts, or prep data, clean data, transform data that could be given to a data scientist to do some kind of ML on top. And we cover all different kinds of technologies. We've been going through the roadmap that we covered in Data Engineers Lunch number 1. If you're interested in what that roadmap is, you can find the blog or on our YouTube, youtube.com/AnantCorp, and we have all the recorded Data Engineers Lunches available on the channel. So this is generally a part where if we're in person, take a couple minutes to go speak to someone new that you potentially haven't spoken to. But because this is an online event, if someone wants to say hi, we won't pull any teeth, but if you're new here, what do you do with data engineering? What do you hope to get out of this event? What is something potentially you could speak on? If you want to say hi, you can go ahead and unmute yourself and say hi.
Hi, my name is Mark. I'm new here. I'm a recent graduate of the University of Toronto. I know you guys are in DC, but I'm in Canada. I'm just looking for, trying to stay in school, make sure that I keep up with everything new with data engineering. I do like, thank you. I am looking for a data engineering job currently. So that's why I'm here, and I'm trying to connect with everybody regardless of where you are in the world. So thank you for having me.
Yeah, great to have you, Mark. Anyone else want to say hi?
Hi, everyone. My name is Pavitra. I'm from Dallas, Texas. It's my first meeting here. I am actually an open source developer. I use R a lot, but I'm actually working for the last 3 years. I was hired to be a data scientist, but it turns out that all I've done is data engineering. And I use a lot of enterprise in my work. Escape, Snowflake, SQL Server, REST APIs, etc. So I haven't gotten to do any of my data science part of my job as yet. So always interested to learn new and interesting techniques. We are planning to switch to Pentaho from Escape. So curious to see what tool sets you guys have. So
great. Yeah. And if you're interested in giving a talk on something like Snowflake, you can reach out to us. I'll drop my email in the chat. And yeah, if anyone here has a topic that they would like to talk about or learn and then give a presentation on it, feel free. You can drop an email to me or Rahul, and we can help you get that set up. Alrighty. Let's go ahead and move on to the next section, group roles. If you have a question, ask it. We are a community here, so it's a shared knowledge base. Just some obvious things: be polite and courteous to others. If the speaker, depending on the speaker, they might have some preferences in terms of when they like to have questions or what are good stopping points. Generally, if you have a question, you can drop it in the chat and they'll get to it at a good time, or you can speak up. So if someone covered something and you have something to add, you can generally speak up and provide. So here at Anant, we design, build, and manage global data and analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life here. DataStax is a partner and a sponsor. GW University is also a sponsor, especially when we're having in-person events. They usually provide us with venue space. We have some local and institutional sponsors as well. And this is generally an area, if anyone has, as Mark mentioned, if anyone has a job or is looking for a job, if anyone has any meetups, I believe Mike sent something in the chat as well, or if they have any hackathons, conferences, and classes that they would like to publicize, you can go ahead and drop it in the chat or speak up if you have anything coming up. Okay. So we are hiring here at Anant. We're looking for full-time or part-time positions relating to data platform operators, data platform engineers, and data platform architects. If you are interested, you can apply at careers.anant.us. And with that, some upcoming events that we have. This event happens every Monday at noon Eastern, and you can find those at meetup.com. You can also find Anant's upcoming events at anant.us/events. And we also, in addition to holding this data engineers lunch every Monday at noon, we also host Cassandra lunch Wednesdays at noon, where we cover topics related to Apache Cassandra. And some upcoming topics. So Spark SQL that happened last Wednesday. On Wednesday, upcoming, we have a topic on machine learning with Spark and Cassandra. And then next Monday, we'll have a topic with here at Data Engineers Lunch on Airflow and Spark. And with that, we'll pass it over to Obi, our speaker today.
All right, hello. As you have heard, I'm Obi Anamnachi, an engineer here at Anant. And today I'll be giving a presentation on Pandas for data engineering. As previously mentioned, this is part of an ongoing series on Python ETL tools that was started a couple weeks back, where we did an overview of several tools and we did a demo for bonobos. Generally, I prefer to get questions in the chat while I'm presenting. But if we're in a section where I'm stopped, like we're transitioning into the demo, or just I'm stopping in between slides, feel free to ask just by unmuting yourself during that time. Okay. So we're talking about pandas today. If you were here for that previous overview and demo of bonobos, we have a sort of dichotomy going on there in terms of what Python ETL tools actually do and are capable of. And the split that we sort of saw there was that there are ones that are more suited to scheduling tasks and managing your sort of jobs, and then there are ones that are sort of there are ones that are meant specifically for managing your data. They have an internal data collection representation, and then they have built-in methods and functions for working with that data. So Pandas is one of the second type. It describes itself as an open source data analysis and manipulation tool. So not specifically an ETL tool, but because of the other functionality included, it's useful for that as well, on certain scales anyway. So it's really a collection of data types and methods and functions involving those types. Specifically, the two main data types that make up pandas are series, which are sort of 1D storage object data type, capable of containing any type of Python data. You could put in normal Python types, you could put in NumPy types, you could put in Python objects. And while it shows itself as 1D, it actually also contains a customizable index alongside your data. So if you don't specifically define that index, it just assigns it 0 to n. Sorry, I don't know why I said 1 when counting starts from 0. But you can also define your own indices. You can use letters or Python objects or whatever. And that is how you get your data out in that circumstance. And you can operate on your data within the series without using loops. If you were working with normal Python lists, well, sometimes there are things you can do without using loops. But inside NumPy arrays and inside series, at least ones containing numbers, you can operate on the entire array essentially without loops. And data frames are 2D data structures, so more like a matrix in this case, or a table. And they're made up of typed columns. Each column has a specific type and can only hold data for that type. You cannot have multiple types in a single column. And it's constructed from dictionaries of 1D data structures. Generally, in the constructor, you can give it lists, series, NumPy arrays, other types of data collections. You can give it dictionaries of dictionaries, and it'll still manage to build you a 2D table array if your data fits that. And then inside, it's actually a collection of series, which is what allows a lot of the processing that Pandas has included. So indices from series, because it's made up of series, they have their own indices. They now act as row labels. And then there are also, in the bigger data structure of the data frame, column names, which acts as column indices. Yeah, so you can select an index. Well, what does that sentence even mean? Okay, what it's supposed to say is that the syntax for selecting an indexed row from a data frame is the same as the syntax for selecting a single item out of a series list. So first, indexing and selection. When you're selecting from a series, you can select a value or set of adjacent values via their indices. If not past a specific type of index on creation, it will give you a normal numerical index from 0 to length of your data -1. You can select slices of that data. You can select from your data based on conditions. And you can also select specific items out via an array of the indices of those items. And then when selecting from a data frame, you can select column with the column name. You can select a row by its label using lock. You can select a row by its integer location using ilock. So data frames essentially have two sets of indices, one that's the actual indices of the series of lists, and then one that is just an integer location index. You can slice rows, and you can also select rows by Boolean vector. So if we're discussing this in the context of Python ETL tools, we need to know its capabilities for extracting data and loading data. So Pandas, as it exists, has a whole bunch of built-in types that you can read from and write to. As you can see, the main one I think it was built for was CSV, but it also includes JSON, HTML, and then even things like Parquet, which is, yeah, it's here. SQL statements, queries. It can query Google BigQuery. And even if you're not using one of these formats, it's probably possible to get data from, say, a Cassandra table, which internally is stored as SS tables, but you can get it out as JSON and then load it in to Pandas if you wanted to. Okay, so we've covered the extraction and loading steps, just need to cover the transform step. And that's what we're talking about here, operations. So binary operations between two values are applied sort of pairwise to a Pandas data frame, and they're sped up via specific Python libraries, one of which handles the chunking, caching, and multi-core parallelization, and one which handles the Python interaction, which is the C interface for Python. So what it's doing under the hood sometimes is that it's sending out all your values to be, and then all your actual operations are taking place in C for increased speed. And then there are binary operators like add, subtract, multiply, and divide inside Pandas already that are flexible, meaning that you can decide when you use them how they handle higher and lower dimensional objects. So when you're, say, multiplying a series with a data frame, you can decide how that interaction takes place. If you wanted to multiply by rows, if you wanted to multiply by columns, that sort of thing. And how they treat missing data. In terms of missing data, Pandas uses nan as its value for missing data, the specific numpy nan value. And you can define how your functions that you're using treat that missing data without defining a new function for it. So if you wanted to add two things and it didn't have this capability, you would need a separate function for add two data frames and then a function for add two data frames, only this cell is null. But in this case, you can define how it handles that. Maybe it fills in the null with a specific value. Maybe it ignores that row altogether. You get to define that in your arguments for the addition or multiplication, whatever. It is theoretically possible to compare two data frames using the double equals Python equality test, but the method doesn't work well with missing values because not a number, your null, your missing value, does not equal itself. So therefore, they provide their own equals function for a comparison where missing data is equal to other missing data. And it also offers tools for statistical methods like mean and standard deviation. And you can also change in the arguments how those functions interact with missing values. And there's a bunch more stuff not really mentioned here, like how Pandas can do joins and merges, group by. There's a lot of functionality in Pandas, but that's not a lot of it is relevant to the demo that we're about to go into. So we're going into a demo now. If you want to follow along, the code is in a notebook here, but will be transplanted onto the Anant GitHub account and go out publicly after this. And all our example for today is contained within this IPython notebook. We're going to use Pandas to do a sort of machine learning pre-processing sort of task. We're working with the Pima Indians diabetes database, and it's similar to, if you have seen the previous, it's pretty old at this point, but there's a Spark machine learning with Spark and Cassandra series up on our blog and YouTube channel. And that uses this data set as well. We're essentially replicating the pre-processing done there, only this time in Pandas. It was in Spark previously. So if we, I don't know, that we can actually, okay, yeah, we can look at this data. And it's really just a CSV of a whole bunch of numbers. There's not really any detail here. When I downloaded it, I got like a text file with descriptions of what the columns were, but not much else. So what we're going to do here, first thing to do is to load that data into a Pandas data frame, which we're doing with the read CSV function because we have it in a CSV file right now. And because the headers aren't, the column headers aren't included in that file, we're just giving them in. They were in a text file that was with this document, but has been lost to time. Well, I mean, I could find it again if I needed it, but I have the header names here already. So you can see that the data that we're working with is times the person has been pregnant, plasma glucose readings, blood pressure readings, tricep thickness readings, serum insulin, BMI, diabetes pedigree, which is a sort of measure of the incidence of diabetes in their family history, I believe, age, and then a label, 1 if the person had diabetes, 0 if they did not have diabetes. And the sort of machine learning task here would be to split off some of this data or generate new examples, and then use a machine learning model to predict if a given person with a specific number of times they've been pregnant, plasma glucose, blood pressure, et cetera, has diabetes or does not have diabetes. But as you can see, even in these like 5 values up here, a lot of people don't have serum insulin readings, and they're represented here as 0, which would definitely throw off the model. And you can see there are also others like this tricep thickness reading is 0, but a tricep thickness of 0 does not make any sense as an actual measurement. So the things that we're going to need to do is figure out in which rows 0 should count as a null, and make sure it does. And then either, this is a choice you would make when preparing your data for a machine learning model, whether you drop null values or you impute them with data based on the rest of your data. And both of those have drawbacks and advantages, but we will actually see both. So first, let's look at the counts. We have 786 examples. This is extremely low for a machine learning application, but this is a specific cohort of people with like specific historic measurements. And it's a very small data set because it's mostly used in learning and teaching. So the first thing we're going to do, this isn't really necessary for this data set, but we're going to show the breakdown of labels. As you can see, we have a lot more people without diabetes than who have diabetes in the data set. So this might be something you wouldn't want to mess around with it, but you would want to check your future data to see if that trend holds up potentially, as well as your model results. So what we're going to do is we're going to, for the column blood pressure, we are going to check how many values are 0. And we got back that there are 35 0 values. Value counts breaks down all the distinct unique values by how many times they appear in your data set. And what we've done is we've got the result corresponding with 0. So it doesn't tell you how many null values are there. You would need a different line of code to do that, but we actually will do that later. What we're doing is counting zeros. And this is a different way of counting zeros. This one theoretically would also work for nulls, where you using diabetes DF is in 0. So it matches, except the only thing in the array of things to match with is 0. And We sum them all together. So you can see times pregnant has 111 zero values, but having been pregnant 0 times is a totally valid value, whereas a plasma glucose of 0, probably not. A blood pressure of 0, no. A tricep thickness of 0. So there are these 5 columns, which all those zeros are probably null values. So the next thing we're going to go do is actually replace them with null. And the way this works is you're setting a column in your current data frame equal to that column where all the zeros have been replaced with nans. So when we look in here now, there are no more 0 values in those cells. They've all been replaced with not a number. And we can make sure of that by counting zeros again, and you see that they're all gone. Well, they've all been replaced with null. And we can see our counts now where numbers in several rows have gone down by that amount because null values don't show up in a count. So next thing we're going to do is we're going to drop, well, we're creating a new data frame here by taking the old data frame and dropping all values that are all rows in which any value is null. So we go back and we do the count again, and there are 392 actual rows with no null values at all in our table. And that might be the data set you want, depending on what your actual application is. If you think that any null value could be throwing off your calculation and that filling it in might cause a different kind of skew, it's possible. And if you have enough data to still accomplish your task at all afterwards, you can just drop all null values and then run on that data set. So we can then output this to, well, an HDF5 file for HDFS. If we had a cluster, we could use that with it. But now we're going to do the other thing where we take that same data frame with all the nulls in it. We're going to count them. This is the actual like filter sum for calculating how many nulls you have in each column. Whereas this one up here is the normal count that doesn't include rows. And if you added this one to this one, you'd get 768 all the way across the board, like in our first reading up here. So the next thing we're going to do is called in machine learning imputation. We're imputing values where there are nulls, we're replacing them with numbers. And in this case, the way we're doing that is we're taking the mean of all the actual data in that column and filling it in those places. The mean imputation is good because it won't affect the overall averages of your data on the whole. But there are other imputation methods, zero imputation, median imputation, machine learning imputation. If you want to set up another machine learning process to take the data that's there and estimate what the missing values are based on that, and then take your filled in data based on machine learning and put it into another machine learning model, you can do that. And it is sometimes better than mean imputation and sometimes it isn't. But in this case, we're doing mean imputation. In the Spark Cassandra example from machine learning with Spark and Cassandra, we used a Spark MLlib object, a particular imputer. sklearn also has an imputer object. But we're doing it manually here. We call the fill in a function, which takes all the places where your data is null and fills it in with whatever you decide. And in this case, what we decide is the mean for that column. And we're using skip in a equals true because we don't want it to try and take the mean of rows that don't have any data in that column. because then it would probably crash. I actually don't really know how NumPy not a numbers. We might just get back nan, or it might crash. It's hard to say. But once we run this, we can check if there are nulls in any of our tables. And now the answer is no, because they've all been filled in with that mean value. And then in this case, we can use the toHTML function, which returns a string instead of an HTML file in this case. So we're outputting it to a file ourselves. And then we can open up that file and see that it's just our data in a table in HTML. I elected not to do the actual machine learning this time because we have examples of that, or at least an example where we use this data set and we train a model and we see the predictions. But just as an example of what's possible in pandas, or at least the sort of things that that pandas generally gets used for, because mostly what I've seen people use it for is ETL stuff in preparation for machine learning. Although if you have other ETL tasks, it's probably up to that as well, depending on the scale. And that is all I've got for today. So if there are any questions, I will take those now. And since we finished pretty early, there will probably be time after that for general data engineering discussion.
Hey, thanks. Thanks, Evie. So when I've used Pandas, not to the degree that kind of how deep you went in, because a lot of the work that as you know, I do is more related to Spark. Spark has data frames as well. There's some kind of commonalities, but they're definitely different. What are the main differences between like Spark data frames and Pandas, and in terms of functionality? And I know there's another one I haven't used yet. It's called Koalas, which is like Pandas syntax on top of Spark. I don't know if you had time to play with that.
No, I haven't had time to play with koalas, but something to look into for the future. And I guess the main differences between Spark data frames and Pandas data frames, I don't actually know too much of the underlying structure of Spark data frames. You could see in the explanation earlier just how Spark data frames are like very specifically built on or Pandas data frames, sorry, are specifically built on the Pandas series, and they have the same sort of index notation, and they have the same sort of like underlying interaction. And then I think the main thing there is that what underlies the series is NumPy array, and under that is Python. So depending on like what's underneath the Spark data frame sort of structure, which probably ultimately ends up using Java types in some way, those sort of act differently in response to stuff.
Gotcha.
Question in chat, isn't Pandas memory constrained? You wouldn't use this on big data set. That is completely true. So Pandas is memory constrained. It's limited to this one system anyway, at maximum. Whereas for big data sets, I'd probably recommend Spark. It even has data frames and similar sort of like API setup to make use of them. You could use Google Colab for bigger data set and use PySpark to use Spark and Python. Yes, exactly. Any other questions?
So I guess I don't have that much kind of like the bleeding edge experience, but the I know in, for example, when we do some of the neural network stuff, we're generally using things like NumPy, because a lot of that is getting parallelized and executed in the GPU. And in NumPy, I know that, if I remember correctly, maybe I'm thinking of a different library, but you can have basically, as a column, you can have kind of a function so that's executed when you read it, right? So it's a function on the, I think in Pandas you can do that too, right? You can have a column that's it's a function of what's in the actual static scalar data.
I believe so, yes. I know that Pandas has a lot of that same capability, because it's sort of built on NumPy that way.
Gotcha. Cool.
And a comment, PyArrow also is up and coming for large data set readings.
Yeah, somebody was talking about Arrow the other day. I think it was Jay. Arrow is kind of the in-memory data format that everybody's rallying around, Apache Arrow. So it'd be interesting to get a couple of demonstrations on Arrow in general, right? How to use it in different platforms, including Python. Yeah, good point. Definitely. Awesome. Yeah, thank you. Appreciate it, Obi. I think it's probably time to wrap up. Unless anybody has any questions or wants to discuss data engineering stuff in general. Okay, great. Awesome. Thanks, Obi. Appreciate it. Great. And looking forward to the next one on koalas. I keep adding stuff to your queue. It's on your to-do list. Awesome. Thanks, everybody. Have a wonderful rest of the week. And see you guys here next week, same time, same place. All right.